All right. I hope everyone's having a nice week. Let's begin this session. So before I dive into the topic, before I say anything, I want to give you a slogan or a quote to keep in your mind as we go through the work. And every time I iterate over something or mention something important, I want you to keep this in the back of your head. And it's tactics win battles, logistics win wars. And I'm pretty sure you're all familiar with the difference between tactics and logistics, but I'd like to emphasize that tactics is how you as individual team members can work. Whether you're working as a software team, or you're working in an oil field, or you're working in a ranch. Logistics is how we as a team, as a unified functional unit, can deliver to our endpoint and can deliver our consumers a quality product that matches with our mission. So keep this in the back of your head. Because today, we will be talking about the machine within the machine. First of all, a special thanks to Code with Sarah. Special thanks to my friend Hassan for setting this up and making it possible. And a special group for GDG, Google Developer Group, and a special thanks to the Natus University AI Club. Before I say anything, let me introduce myself. I'm Abdulrahman Al-Suedan. You can just call me Abed. I'm the founder of Pume. And Pume is the world's first AI summarizer made for med students. Now, before anyone asks, we're not a ChatGPT wrapper. We're actually a natively made natural language processing model that was trained on huge sets of data for med students. Well, you can just email me on abel@pumeai.com. You won't find me at LinkedIn for now, and that's my sin as a technical founder. But I'm going to be there, and I promise Sarah and I promise Hassan I'm going to be there very soon. So if you need anything, whether it's a question or an event, you can email me at abed@pumeai.com. Just a little bit about Pume. Again, we're not a chatbot. We're a native NLP model, and we're the only summary tool that includes images and the student summary. We're going to be having an open beta on February 16th, and you can just check it out on pumeai.com. We look forward to seeing you guys and hearing your feedback. Today's session, we're going to be covering four main topics or 4 steps. The first one, which is a personal favorite of mine, is start with why. It's your purpose as a team, but it's also how fast you move through the DevOps cycle. And what does every stage mean? The second one is the Pume team. I want to give you a sneak peek into how we as a team can operate, whether it's DevOps, whether it's programming, and even team dynamics. Then, we're going to talk about DevOps in depth. And finally, we're going to be breaking production, which sounds odd, but let me just move my screen out of the way. So you guys can see. There we go. The term breaking production is trauma-inducing for people. But then again, we're going to be having a test dummy and compare how we can elevate this from a testing setup to a production setup. We're going to see how an API can fail under load. All right. Now, remember in the beginning, we said start with why. And it's actually the name of one of my favorite books by Simon Sinek. He's an amazing author. And he has an amazing story where he says that the Wright brothers, the people who took first flight and recorded history, were competing with a government-funded team of 20 individuals. The Wright brothers were just 2 brothers in a garage, using their bicycle parts, using whatever they found, using their tools, trying to go into the air. Funny enough, the Wright brothers succeeded, and they entered history as the people who took humanity to the skies. And because they started with why. Before you do anything, before you develop your product, before you even write a single line of code, ask yourself, should my product exist? How am I going to produce it? What are the team requirements? What are the tech stack elements that I'm going to need? And how is it better than ChatGPT? And this is a funny one because the standard, the global standard for what makes an AI product is asking the question, well, what can this do that ChatGPT can't do for me? And finally, I'd like to highlight something for all of you aspiring founders and for anyone trying to program something that's trying to make a profit out of it. The toughest journey ever that you can go through is taking the consumer or taking the initiative from his eye to the credit card. And what I mean is you want him to be exposed to the product, but also get to a point where he says, I need this. This is going to make my life better. So I'm going to pull out my credit card and just pay for it. The subscription, whether it's $10, $15, it could be a credit subscription, whatever it is. Where there is a need, there is value. And where there is value, there is revenue. And this is where DevOps come into play. Asking yourself, why am I doing this, is eventually going to lead to the previous two steps of how and what. Simon Sinek, in one of his presentations, says, Apple is probably the best marketing agency in the world. Sure, they make a beautiful product. I hate their OS. But they are, without a doubt, masters of marketing. And the reason is, if you ever watch an Apple ad, they're going to say, because we believe in evolving the human race, we build amazing machines. Now, in our sales point, the Apple II or the Mac, they started with why? They started with the purpose. And because they had a very solid plan, they dominated the market. The DevOps cycle, I'm pretty sure you've seen it a lot, but we're going to be covering it generally today. But we're going to be going a little bit into depth, into planning, coding, and testing. Let's unfold the loop and cover them generally. So, when I say planning, I need to collect market data. I need to collect user feedback and competitive intelligence for insights. What is something that I'm going to do that my competitor isn't doing? I believe there are three main steps for any successful product, or three core elements for a successful product. Number one is, how am I competing in the market? Is there a demand for what I'm doing? Number two is, how aggressively can I market this product? Is it hard to market it, or can I market it with an advertisement? Or my favorite, and which we're doing for Pew, is can I market it to an individual, to my friend, to my roommate who's a med student who's not sleeping because he has a lot of work crammed on him? Number two is coding. Coding is done through setting clear, measurable objectives that align with your business strategy. Now, usually we relate coding to the fact of programming, which language am I going to use, which framework, which IDE I'm going to use, and these are all amazing things. But coding is only as good as the goals that you set and how measurable they are. Number three, building. Break large, huge chunks into smaller elements and see how can I give ownership of this specific part to my backend developer, to my marketing team, to my front-end developer. Number four is testing, which is identifying the relationships between tasks and sequencing them for optimal workflow. And the reason I say this is I'm not going into the details of coding. I'm going to the details of how we as a machine that produces products work. That is why I say I'm going to test this specific endpoint because I know it's going to have a lot of traffic. So it's more about knowing the relationships than it is about knowing raw code. Number five is releasing, which is combining all the elements, having version control on them, deploying them. And we also have deployment, interacting with your VPS, your tech stack to run the release, operating the product, which is just being on standby for maintenance clauses, for tickets that come in, certain errors that can happen. And finally, which is the easiest one, monitoring. And that is more of an internal thing where you monitor your hardware and you say, okay, so we have this new feature and we have, let's say hypothetically, 64 gigabytes of RAM on our virtual private server. How much of it is being used? Are there any memory leaks? Is something breaking my system as I try to service customers? Now, let's go into planning in depth. This is an amazing roadmap, and this is actually how the Pume team works. First of all, we collect ideas, and the ideas never come from us. Sometimes there's a feature that I want to see, but no customer really needs it. The customer is always your reliable source of ideas. What they say goes. So we collect them, we filter them, and then we ask ourselves, is this going to make my product better or worse? When I implement it, is my product going to be too slow? Is it going to be too expensive, too cheap? Is it going to be oddly priced? Then we ask ourselves the age-old question of, can it be done? What do we need as a team? What are the financials that I need? Who does what? Giving roles, giving functions, giving objectives. And finally, speed and aggression. And I cannot emphasize on this importantly enough. In my experience, there isn't a single product, including Pume, that survives contact with the market. And what I mean by that is your initial idea is going to change. It's definitely going to change. It's just how fast you can adapt and how fast you can execute to these changes do you actually succeed. Airbnb is one of the world's biggest software as a service company. One in every $1,000 traded worldwide belongs to Airbnb or is part of the Airbnb cycle. Airbnb started as a mattress company. They were selling mattresses to people, but they found that the market needed something else. So they pivoted not once, not twice. They changed their product 3 times. 3 times before they reached something that made their mission be possible. And there are certain DevOps best practices that I want to highlight for you guys. The first one is prioritize ruthlessly. I need to know what is the most important thing of my development lifecycle. Number 2, communicate regularly. So, an isolated team is a team that's doomed to fail. I text my team members, my programmers, my colleagues every day. And sometimes, we're not working on something, sometimes we have finals, but I just talk to them to remind them that we're a team, to remind them that we're together. Building flexibility is an amazing thing you guys can do. And as I said before, you need to be flexible with the market. You need to know what's going on. Your initial idea is bound to change, and I cannot highlight this enough. As an engineer, you need to understand that your ability to modify your idea and then releasing it and modifying it again and releasing it in this closed loop is what decides your success. Setting measurable goals. This is one of the most important things ever. If I say to my team, we want to release the summarizer within 2 weeks, they're not going to be able to manage it because every one of them works as an isolated unit. But when I say within the next 72 hours, I need the terminology section ready, I need the UI bugs that we identified finalized, they're specific, they're focused, and they can start working. Now, the demon, the devil behind all of humanity's failed engineering projects, overcomplication. Do not ever overcomplicate what can be done in a simple way. Terry Davis is an amazing programmer, and many of you have heard of him. He says, a genius admires simplicity, and a fool admires complexity. And the final one is reviewing your work frequently. Ask yourself, okay, can I change this? Can this be done in a better way? Not in a complex way, not in a very detailed way, but in a generally better way. Now, products are only as good as the team making them. These are Adam and Kareem, they're backend developers at Pume, and honestly, they have such a high caliber of work and work ethic. And because we're such a high caliber team, we're able to deliver. Then again, even if we were a high caliber team, if we weren't abiding by the previous steps, by these best doing, because we're only 5 programmers, by the way, it's our dynamic. It's our objective. Now, this is the last slide that we're going to be looking at, because after this, we're going to be doing some graphs. I'm drawing some 3D elements for you, just to spice things up. Most software as a service tools look like this, and I just want this to be in the center of your head, because I don't want you to think, am I doing this wrong? I want to ensure that you guys understand most products in the world have the basic skeleton of front-end framework, API type, and back-end architecture. If you pay attention to what I say at back-end architecture, you're going to see that I said vibe code with Kosher. Now, I'm not against vibe coding, but I'm not with it. I think AI has a lot to offer people. I, as a programmer, use it almost every day. It's just certain parts cannot be automated. They cannot be thrown to an LLM unless you understand what you're doing. And even if you do, you need to have Kosher. So that's what I said, vibe code with Kosher. Now, let's brainstorm ideas and let's visualize, but then draw a testing architecture or an architecture that most people think exists and a real production architecture. So let me show you guys. I hope you can all see my screen. I'm just going to give you a moment to load things. All right, so this is Mr. User. He's just a regular user accessing your product and trying to interact with it. Most people think the way the architecture looks is like this. You have the user, and then you have them interacting with a client. Let's use the shape for it. Right? This is a client. And what I mean by a client is the tool that you use to access or to interact with your server or your endpoint. Most people think that after this point, after the client point, that we directly contact our server. And let me just draw another line here. Let's go for this, which is a EC2 instance or an Amazon. Right, so this isn't what an architecture looks like. Sure, if you're starting out and you're trying to theorize your way through things, you're going to say, yeah, there's not more details to this. You might even go as far as saying, yeah, okay, there might be a database somewhere which interacts with my system. Let me draw a line for you guys. But this isn't sufficient enough. This isn't production scale. This isn't what makes sure that your SaaS reaches your audience in the way that you want to. Let's remove these things and let's look at it from a different aspect. Same old thing. You have a user, you have their client. And let's say they want to connect to our endpoint. In almost any SaaS product in the world, in any of them, you're going to find that your request never hits the server directly. What it does hit is a load balancer. A load balancer is how a server protects itself. When you have 100 requests, 150 requests, 1,000 requests coming in, how are you going to handle them? How is your server going to accept them and release? I'm not even talking about processing them. What I am talking about is being able to take them all in. So that's where a load balancer comes in. One of the load balancers that we do use is actually, and I have the chart for you guys here, and you can see here that you have multiple servers in any setup. It's not always only one server that you encounter. There's going to be more than one server, and they're all going to be protected by a reverse proxy or a load balancer, in another name. So we have the user, we have the client, we have the load balancer. Obviously, the next stop is going to be the server. Well, let's just put it down. And let's make it blue for a change. Because, pink themed. So, here's what our setup looks like. In our case, we have two individual servers. They're protected by a load balancer. And then finally, we have the data center. I'm going to go a little bit further down with the data center because we have them hosted separately. They're never hosted in the same service. And this is what I'm trying to say, is that you never put all of your eggs in one basket. In our DevOps lifecycle, I need to get to a point where I ask, is this too much processing in one spot? Is this too much requests coming in and out into one dedicated server? So scaling is the target of any team, and DevOps makes that possible. So obviously, we have the connection here. We also have the connection here. And finally, and this is something important, and I really, really want to highlight it to you guys. The server never sees the user. The database never sees the user. 90% of the attacks of cyber crimes, of viruses, of DDoS attacks, they happen either by attacking your database or attacking your endpoint if you don't have it protected, by load balancer, by an extra layer that really puts that space between the evil threats of the programming world and your servers. Now, I want to put a line here, and I want to say that this cycle here, this never happens. You never let your database interact with the user. That is why any request for what a user needs will always come from the server. Your server is your friend. The way you set up your work, the way you've set up my interactions, my connection pools with the database, this determines how long and how powerful your service to the customers can be. So, just a general review, I want you to remove your old imagination of what an architecture is, of what a production setup looks like, and I want you to say, oh, okay, this is the global standard. I think you guys cannot see my camera. Let me fix it very quickly. All right. Now, I want you guys to understand that this is what any production setup looks like. This is the global standard, and I hope to know that you guys, from this point on, whenever you try to deploy something, you at least keep this in the back of your head, and you say, oh, okay, I need to be working at a standard and at a level that is possible that makes it possible to serve my users, that makes it possible to maintain a level of quality similar to my competitors. Now, this all sounds great, this all sounds lovely, but I believe in seeing practical work. I believe in seeing things happen in front of my eyes. And I want to tell you a story. Almost a year ago, I was doing a project for our university. And that project was, very simply, until this day and age, until this date, my university doesn't have a schedule system for students. And embarrassingly enough, whenever I wanted to go to my lectures, whenever Hassan wanted to go to his lectures, he would literally have to open an Excel sheet that included all of the lectures and all of the lecture halls. And I'm showing it right in front of you. We literally had to do all of this and look lecture by lecture. We had to look date time by date time. We had to look, sometimes we had clashes. And to this day, we never really, as students, had something that organized our daily schedule. So, as an engineer, I was fed up. And then I was wondering, why can't we have a very simple endpoint or a very simple API that took our courses and produced a schedule like any other university out there? Now, I implemented the backend for this project and I worked with the university. It worked very well. But I recreated some of it and I vibe coded some areas and I purposefully left some weaknesses, some vulnerabilities. Because I'd like to explain to you where vibe coding might kill you as a product. And I want to resolve them with your help. So, I hope you can all see my screen. This is the graph that I presented to the university, and this is the foundation that we worked with. And what we said is, okay, we don't want to make something very complex. Remember what I said, you never overcomplicate your work. We said, I want to add a button to the page of the courses, and I'm going to show it to you in a moment. There it is. I thought, well, maybe I can add a button here that would generate the schedule for the student. Instead of having to go through the tedious process of going to their Excel sheet, and then after the Excel sheet, you have to write everything down, and after writing everything down, you might have a class, you might have two, you might have three. This process alone made it really discouraged some students from going to the lecture. So as you can see here, I have some courses, I added some courses, and I thought, from these courses, I can create the schedule. So the student would click the button, right? And then we'd get a JSON object with the student name and the courses, and then it would hit the endpoint, right? And then the endpoint would go to the original timesheet, which is actually available on one of the websites of the university. And we'd say, okay, we'll take that Excel sheet, we're going to process it, we're going to see if there are any clashes, something I can't resolve, something I should resolve, and I'm going to say, okay, here's your schedule, and here are the issues in it. Really simple work. And we called it Calendai. The reason we called it Calendai is the hope that eventually we can add a statistical model and a machine learning model to this product. So, here's the button. Let me just show you the button very quickly. And obviously, it says here, my timetable. This is, by the way, just a mock page because I just want to show you what we're doing. And let's say I'm a student and I have a random number of courses. I'd click my timetable. Excuse me. And I'd say, well, here's my timetable, right? I'm going to give you a moment to look at it. Let me just fix something very quickly. Sorry about that. I had a technical issue that I needed to fix. So, as you can see here, the student will end up, well, with his own courses. It's a very simple pipeline, straight to the point, and you and I are going to be exploring it together. Well, here's the timetable, and very simply enough, it would go through a Python function. Now, this is where your journey as a developer begins. You say, what do I need in my backend? And how do I secure it against threats and vulnerabilities, right? Because remember, the golden rule of any successful DevOps team is efficient planning. Obviously, I had the endpoints running on. I had an analysis one and I had a submit one. And I said, okay, well, let me get it working. And then I made a search function. I'm not going to go into the details because we're focused on how we work as an engineering system rather than the individual programming bits of everything. What I'd do here is I'd say, okay, let me take the data frame from the Excel page. Let me make it into a timetable object, right? Let me make the courses. Let me go through them. Let me see if any clashes exist. Let me say, okay, what is going on inside that schedule that I need to present to the user? It could be the lecture, it could be the day, it could be the start, it could be the end, whatever it is. And obviously, I had my main runner. The main runner is a React app. And then I said, okay, hold on. So my backend can serve this to students. But any backend system without a good front end is quite useless. So I planned it through the DevOps loop, and I began coding. We're using VS Code right now. But as I was showing you what was happening, there was a vulnerability. There was a weakness. And I'm going to show it to you in just a moment. This is our vulnerability. Well, let me just take a 3-minute break. I need a 3-minute break because I'm having a technical issue. Let me just fix it really quickly, and I'll be back in a moment. I hope you guys excuse me. Just have to fix the technical issue. Sorry about that, guys. I was just trying to fix a small technical issue. Anyway, as I was saying, so there was a small vulnerability, and I want to show it to you really quickly. And well, here it is. If I come here, let me just open it for you guys, right? My endpoint is directly linked to this, right? And you can see that it handles the click. There's a function, a React function that says, "Oh, handle the click." But I can just spam it. Well, hold on. What do you mean I can just spam it? I can just keep on clicking the thing, and then I can spam my server, my handler, and you can actually see that it crashed. And no matter how many times I click back now, it's not going to work, right? Because I crashed it. Okay, let me show you guys. You can see how many times I hit the endpoint without a break in between, without a chance for the server to say, well, hold on, what am I supposed to do with all of these requests? And you can see that it actually died. I can't go back. It froze. And this is one of the threats with vibe coding, is that we never do something called rate limiting. Well, you're going to say, what is rate limiting? Let me show you in a second. If I go right over here, right, and you can see that it's fetching a response from my backpoint, right? And then you can see that it's a very basic setup. It's a very basic implementation. I vibe coded the JSX part, and you can see that what should be happening right over here is that I should have a barrier, a rate limit, that stops the user from spamming my endpoint and just killing the service. And that is actually what we refer to in our field as a DDoS attack. This is what we call a DDoS attack. And essentially, what's really happening with your service is that you have so many requests coming in. Your endpoint gets spammed, it gets broken, and your loader, your backend architecture is just flooded. So the first thing that I'm gonna write as a comment right over here is that, okay, this should be rate limited. That, ladies and gentlemen, is our first vulnerability, right? Well, let's see if there's another problem. And this time, the problem is not going to be in the code itself. It's going to be in something being missing. And that is, ladies and gentlemen, if you look at the graph here, well, hold on for a second. We don't have a database, right? We should have a database right over here. And so many vibe-coded tools miss this thing, right? Your database is your long-term memory. If you vibe code something and you say, yeah, okay, well, that works, but you don't actually study and plan and deploy a suitable database for your use case, you're going to end up without the ability to serve users their information. So we're going to go here, and we're just going to name this database. Now, that's the second issue that we have. I think there's even a third issue that we are going to handle, and I'm just going to mention it today because that's not the focus, but I just want to grab your attention for it. And that is, ladies and gentlemen, right over here, the UUID. And now, this isn't really something that is broken, but usually what I see in vibe-coded apps, many people are missing this thing. This is a UUID, which is a universally unique identifier. A UUID is made up of 32 characters. And let me just pull something up for you guys right over here. And the way that is structured is that we make it unique, and all obviously from the name, It's universally unique identifier for every user. Databases use this. Requests use this. But not even this is safe enough. And that is why we have something called a secret key. And I'm not going to be going into it today. I'm not going to be going to the details, but it's really worth it if you guys keep this right over here in the back of your head. Right? This is called a JSON Web Token. And a token is basically a secret key that I can use to verify my transaction between the server and the client. So let us write for ourselves the three main killers that we had. This is number one. And this is number two. This is number three. And we're going to say, well, the first main issue that I had is, without a shadow of doubt, not being able to put a rate limit on my endpoint. Right? So we have three major culprits. The first one being not being able to put a limit on the API endpoint. Right? The second culprit, and let me just include this for you guys. There we go. Put this right over there. Right? And I'm going to say danger number one. No API rate limit. And as I said, without a rate limit, you expose yourself to DDoS attacks, but you also expose yourself to a backing up service. Right. Now, danger number two. For danger number two, we have no persistent memory, which is a database. It could be a Postgres, it could be a MySQL, it could be a MongoDB, but whatever it is, you need to have persistent memory. It could be an EC2 instance, it could be an Azure, whatever it is. Do not work thinking that it's only backend and front. Danger number three, and as I said it, UUID is never enough. And as I said, you need a token or a secret key. They're safer, and the way they're generated, the algorithms that generate the secret key are much safer than a UUID. Now, you might be wondering, why did I go into the details of implementing a backend? Let me just do this for you. Why would I go into the details of the backend? Because these taught me and taught the Pune team golden rules for implementing a production scale architecture. And I actually want to share with you guys something that we use every single day, that we as a team look at to understand what's happening in our backend. Let me open it for you. Now, you might be looking at this and wondering, well, okay, hold on. This is a huge graph. And it's so many details and it's so many things that are all working together. But it's actually quite simple. And it's all rooted in the lessons that we learned making the project for our university and trying to implement it for our startup, which is Pume. The first thing you're going to see here is that I have a UV-Corn worker. It's something that we call an async. And let me write it for you guys. It's an async worker. And I'm pretty sure you're all familiar with the term sync and async. But when we say async, just to be sure, async tasks can happen not exactly parallel, but they can happen in turn sharing with other tasks. So if I want to say, I want a function to run alongside another function, in a way, that is what an asynchronous worker is. I'm not going to go into the details because we're talking about the systems or the machine behind the machine today. So the UV-Corn worker, the way we set it up, it stops the first danger, which we talked about, from happening, which is danger number 1. We gave it a rate limit. We told it, you cannot be taking more than 10, 15, or 20 requests per minute. That is called server-side rate limiting, and I'm pretty sure they're going to be expanding on it in the next sessions. But this is number 1, and this is the first lesson that we tried to implement in our work. Well, after that, we said, okay, well, we need memory. We need a form of persistent memory. We have Redis. Redis is not a persistent memory, it's a cache. And it's basically a message broker, but the idea is that it is an extension, you can think of it as an extension of our database management, because it is the first stop for the incoming request. I'm not gonna go into the details again, but Redis is something you're gonna be seeing a lot in the future, you're gonna be working with a lot. Then they go through the background process. They go to the disk, and then they go to the background process. And this is something that I want to talk to you guys about. And that is how does a server handle thousands of requests? Most people who vibe code, and most beginners, even if you're not vibe coding, even if you're just trying to program by heart, really miss something that is fundamental, and that is called a concurrent task. Right? And the concurrent task is actually a part of rule number 1, which is protect your API limits. In a concurrent task, you can see here that I have the extract queue, the image evaluation, the summary generation, the post-processing. By the way, these are real steps inside our model. It is very simplified, but this is how our background handles 200 and 300 concurrent requests, right? So you have salary workers. Salary workers are small batches of code. They're small functions. And what they do is they process every chunk or every function in parallel. In that way, whenever you get a new request, your UV-Corn worker only handles that request. Imagine, guys, if, similar to what we were doing here, I had 100 requests come to only one API endpoint that created the Python object, but also accessed the timetable. Then it's definitely going to break. That is why we evolved, and then we grew into a much more intricate and a much more organized background architecture. Finally, we have the server app. And this is actually the name of our real database, and it's PumeDB. As I said, persistent memory is really enough. And it's danger number 2 in vibe coding. And it's really essential that you understand how to implement that server. So we covered these three dangers. And what we did, by the way, for the record, is we essentially, you and I, in this 1 hour, what we've basically done right here, right now, is that we implemented number 1 and number 2 of the DevOps cycle. So you can see how intuitive it is to produce a product. You can see that by setting a clear measurable goal of I want to deliver schedule to users through a specific endpoint that handled clashes, that handled courses, I was able to plan my way ahead. But then I was also able to give myself a feedback, to monitor what was happening as part of my implementation. Let me give you another very quick rerun. Right? So, again, this was the end result, and this is how we organized people's schedules. And this was only done and only made possible through effective utilization of DevOps. Now, there's another thing I'd like to share with you guys, and that is, what are the tools that I need to communicate effectively with my team? Because remember what I said earlier, effective communication or regular communication is really essential for making sure that your productivity, your efficiency as a team is held at a very good standard. Personally, I like to use this Lucid chart or Lucid Spark. It is such an amazing tool whenever you want to share something with your users, whenever you want to communicate an idea that can only be made possible with graphs, with drawings, with charts. And I want to show you guys something. Let me just zoom out a little bit. Of me communicating with my team, using sticky notes and trying to bridge the gap between what I have in my mind and what I can display on paper. Another cornerstone tool of any design process, of any processing, is, without a shadow of doubt, it is Figma. Now, Figma is how we go to the customer as UI or UX designers, and we translate their ideas to UI design. What I am showing you is a small section, a very small part of how we as the Pume team organize our ideas. You can see here on the left side that I have feature by feature organized. And you can see how I'm communicating to my team what I want. So every single line is a feature. And I specifically chose this part because I can share it with you. It's not confidential. But let me just take you guys here. You can see that with the UI tool, I can communicate to my front-end designer that I need this specific color and I need this specific shape in my UI design. Now, let's go back right over here. Let's go back to our DevOps cycle. We said we planned effectively with our dummy production. We coded effectively. We identified points of weakness in our architecture. We built something, we tested it, but now we need to release, deploy, and monitor it. I'd like to share some personal advice with you guys. And it's how can I make sure that anything that I push to my users is monitored effectively. We all of us know GitHub. And I'd like to share with you guys our own repository, which is private. And I want to grab your attention to something which I like to call feature-based branching. What does this mean? It means that if you look at our repository for Pume, you can see that for every single feature, we have a branch or a feature branch that is dedicated to that specific feature. And this is really helpful because whenever I'm trying to work with my team, whenever we begin with something, I can dedicate a special slot in our Figma file to whoever is working on it, especially when you're a small team. And I like to call it the small special forces team versus a huge organizational military example. A small team can be very flexible. It can work really effectively, but they can only do that if every individual member handles one small element. But we can also alternate them. So I can have, for example, a backend developer working on the highlight feature. But if I see that we're lacking behind or that the marketing team is insisting on the translation feature, I can quickly migrate them. Unlike a huge organizational company, which has specific branches, specific departments, specific teams for every single task. That is feature-based branching. And let me just add another detail to it. Which is effective usage of Figma UI design. Figma UI designs aren't just something that you can use to draw your ideas. You can use it to communicate effectively with your team. You can even use them to say, okay, I need this specific feature, but I want to communicate it visually to whoever working on it. This pairs amazingly with feature-based branching, which, as I showed you in our own personal GitHub, how we coordinate branches. Now, what if I'm pushing to production? Because remember, guys, releasing, deploying, and operating are parts of an effective DevOps cycle. What if I've deployed something and I need to say, oh, okay, well, how can I test it on a server that is safe? And this is where I'd like to give you another personal advice of mine, which is use GitHub code spaces. And in a GitHub code space, and I'd like to show you something. In a GitHub code space, I really recommend using a code space as a testing area for yourself, because in a code space, you can make it a replica of your own GitHub repo. So just draw a line here, right? And I can say, this is my production setup. And this is my testing setup. Whenever I make a push from my own GitHub, whenever I make an update or I push a new feature, what I really want to do is I want to check first in testing to have this sort of barrier between it. So, for example, let's call this pumeai.com. This is our live server. But whenever we try to make a push, we always push to a GitHub code space, which is that exact copy of our production setup. And if I actually go here and I draw it for you guys, you can see that we actually have two separate instances, right? And then we have a new feature update that is launching for our team. We're going to name this one the production setup. And I'm going to name the other one copy of production server, which is actually run in our GitHub code space. I'm going to make this a different color. I'm going to make this now. Whenever we make a push of a feature, before we may push it to our production server, before I go ahead and I give a command of, for example, let me just write it for you guys. Right? Before I git push to my production, I always go ahead and I push it to my production server first. So let's call this a feature. Let's call this feature dashboard 12.2. And by the way, it is a really good idea in your own GitHub to name your branch with the date. It is a really good thing you can do, because we can identify when did I make a branch of this specific feature and keep our production lifestyle very consistent, right? Now, let's say I want to push it. I never push directly to the production server. I first push to the copy of the production server, which is running right here on our code space. And I'd like to write something really important here, and I'm going to write it in red. Testing is blue on blue. And you're going to be very confused by this until I explain it. What do I mean by blue on blue? Remember, we pushed our feature, but we never actually pushed it to the production server. What I say by testing is blue on blue, it means testing is done like this. I have two developers, or usually it is a tester. And I say, this is the attacker. And I do this very often with the Pume team. And this is a defender. The attacker is usually, for example, the senior FE developer, senior engineer, let's call it. Could be a front-end developer, it could be a backend. The defender is the person developing a feature, whatever it is, right? And what we do is, since I know what the feature is, usually I have the senior engineer of this specific area, the front end or the API or the server implementation, what I have them is try to exploit. Remember what I said? By, for example, trying to spam something, I try to have them exploit the new development that we made. So what they do is they can try to do an SQL injection, a JSON injection, a 403 bypass, or a man-in-the-middle attack. Or it shouldn't be a man-in-the-middle. Usually it's more of accessing something you shouldn't. Right? So the attacker right over here, literally, and I'm not even kidding, attacks the implementation that we made, right? And they attack it from multiple clients. Usually, for example, they use my device. They can use multiple things. And again, the defender here has to take into account any failures that happen. The endpoint could die, CPU saturation could reach rocket levels, it could skyrocket, and then the person who defended or developed this feature has to say, oh, okay, so this is missing, let me fix it before I push to production, right? And this is a really amazing quote that I like to highlight. Everything coming from the client could be a threat. Remember when I said that we have a client who's accessing our service? Any data they parse, any data they provide in their request can be treated as a vulnerability. It could be a threat to our system. And that is why we first test on the GitHub Codespace. The Codespace never sees users. It is just one attacker managing and overseeing the process of migration from the defender. Once we validate it, once we say, oh, okay, our work is running, we don't have an issue, right? Once I say, oh, okay, it is safe, right? We call it a failure flag. If the failure flag never happens, then I can safely take this new migration or this new feature, and I can very easily push it to production. This entire process is done within 1 day to 2 days, depending on the feature, depending on the availability of the engineer. That is how a 5-member team, remember these guys? This is how a 5-member team is capable of pushing code, of developing a product, and turning ideas and charts and turning them into a real implementation in the real world. Let's go back to our final ending point. This is the life cycle. We planned, we coded, we built, we tested, and I mimicked for you what we do in a deployment and how we operate as a team to make sure that our quality of work and that our server production is never compromised and that we are able to maintain the mission that we're aspiring for. Now, if at any point you feel like you're lacking in knowledge, and this is a personal advice from me, at one point, you're gonna feel like you don't know anything. That's sweet. It is at this point that growth happens. It's at this point that I, as a software engineer, can say, okay, how can I use effective DevOps planning, an effective CI/CD pipeline? And for the record, just to iterate, a CI/CD pipeline, as I said, is the continuous integration, continuous development, which is the loop that happens. It is just the DevOps loop. How can I use these tactics to make sure that I am an effective developer, but that I also don't feel like I am stuck with a lack of knowledge? Let me just open the camera. Yeah. All right. So, as I was saying, this was a set of golden rules and certain lessons that I learned as a developer, and where I reached to a conclusion that said, I want to share these general DevOps standards with people. Because at the end of the day, your product is only as good as the team that is producing it. At the end of the day, growth is never constant. It has fluctuations. But by abiding by a DevOps loop, you can get to a point of an average standard that always delivers to people a very good set of product, set of features, and that is generally what you want to see in your vision or in your mission as a founder. It was really nice talking to you guys. I'm really sorry about the technical issue that happened. I look forward to working with you guys in the future, and more importantly, I look forward to seeing you guys trying our beta in 4 days. Whatever you need, just let me know. You have my email, and if you have any questions at all, I'm looking at your comments, and I'm happy to answer them. I'm just looking at your comments. No problem. Well, I suppose if there aren't any questions, it was really nice talking to you guys. I look forward to working with you again, and the Pume team looks forward to hearing your feedback and in your notes, and we'd even love to hear from you on our email. I look forward to seeing you guys, and have a nice day and a nice boot camp. Thank you, guys.